In this lecture, we will discuss the Dependency Inversion Principle (DIP). This is the most important and is frequently asked in interviews amongst the solid principles. So, continuing with our trend that we will learn it first from our basic analogy. So here what you can see, you have a power source, okay, and we have a light bulb and we have a socket in here. The light bulb is generating electricity. So this is a low level modules which is giving us the implementation details of how the power is generated. The light bulb is a high level module. It is concerned only with the lighting up that particular bulb. The wall or socket, this is an abstraction interface, and the connection via abstraction is done through wires or the socket interface. Okay, so what I want to highlight in here is whenever we switch on this light bulb, it is not bothered about how the power is generated from the source. If we see towards the implementation, the light bulb or the high level module, it is not concerned about how the power is getting generated. We don't go into the implementation details. We simply switch on the light bulb and it gives light. We are not bothered about how the electricity is generated. Then comes the plug and socket. It is the abstraction level, and the low level is the nuclear power plant which produces the electricity. I mean, it has all the internal things about generating the power which we really don't care about when we are lighting the power. So just in this particular DIP, I will first explain the experiment and then dive into the theory for a better understanding. Let us move towards the practical. So, here I have first explained a bad example of DIP. What I have done, I have created a light class and it has a method turn on. Now, the switch class, the light class is a low level implementation, a low level module. And the switch class, see what it is doing, it is taking a light object in here. It is using a light object of this light class. So what it exactly is happening, the switch is getting tightly coupled with the light. So here we are calling the operate method and it turns on the light because this object used in the switch class. This is called as tight coupling. So now imagine that if we want to make our application extended to some other devices as well, say fan, TV, we cannot use this implementation. Why? Because here the switch class is tightly coupled with light only. This is a poor example of DIP and a poor practice which we can use in our software design. We generally don't use this. How we will implement the DIP? Let us see. Okay. So here I have taken two devices, fan as well as light bulb. Okay. So light bulb is implementing this turn on method and it is saying that okay, light bulb is getting on. Similarly for fan method, it also has a method turn on which is getting the implementation details that the fan is spinning. One important point that you guys need to notice here in is both in light bulb, I have implemented it with the interface as well as in the fan class, I have implemented an interface. So what you are seeing, I am implementing the details in these particular classes. This is called as low level modules which are dealing with the implementation details, and the high level module which is interface, it is implementing the abstraction. I mean, it doesn't care about how we are using the turn on methods, or we can say we don't care about the implementation details in the interface. It just says that okay, something is getting turned on. It is just declaring the method, and the implementation details are defined in some other class. Now let us move to a high level module. See, this is called constructor injection, and this is helping in establishing a connection via the abstraction. Notice here that we are not coupling our switch class with the light class or the fan class. We are not making it tightly coupled, because of which it gives us the feasibility that we can use any of the devices into this particular class, as here we don't have any sort of tight coupling that we were having in our previous example. If I move you to here, see, here we were using the tight coupling concept here. Okay, so we cannot use this particular thing for the fan class, because now the switch is tightly coupled with the light. But here we don't have any such difficulty. So now when we use this operate method here, whatever device we have passed in from our calling methods, that would be used. For example, first, I have created the instances for this light bulb and fan classes through the interface. Both are objects of interface, but the bulb contains the reference for light bulb and fan contains that for fan class. Okay. So, oh, I'm sorry. In the program class, first we are creating the instance of switch, and we pass in the bulb instance which points towards the light bulb, and in the second instance for the switch we are passing the interface instance fan is pointing towards the fan class. So what is now happening, this method will be executed both for bulb and fan. These objects will be collected in the device, in the constructor in here, and this device will be assigned different times different values as per the calls which are made in here. Now what happens if I run this application? See, both are getting executed without any difficulty. We have not done any sort of tight coupling here. We have just used interfaces. Okay, so this was the practical implementation. Just to make it more understandable, let us move towards its theory. So this we have covered. Now applying DIP. So as we have already discussed that this DIP suggests that abstractions, that is the interfaces, we have to use instead of directly implementing or depending on the implementation, right? High level code is the bigger picture, that is the high level modules, right, that we have seen like switch, and the low level codes are the implementation details like the light bulb and the fan that we have just seen in the practical implementation. Okay, these are the details and they implement those interfaces. Now, the first point in DIP is the high level module should not depend on the low level modules, but both should depend on the abstraction that we have already discussed, right? The switch module in our example should not depend on the low level, the light module, but it should depend on abstraction. Both these should depend on this abstraction, because in the example here, if you see, both the switch, right, it is also depending on the interface, and these are also depending upon the interface. They both are implementing our interfaces. Okay, the next is the low level modules that I have already discussed. They should also depend upon the interfaces, and they are the ones which have all the implementation details, like the one that I discussed, light and fan, right? And fan and heater, these are some other low level designs. Okay, so the concept is the high level module should depend on interface. The high level module in our case, which was switch, it was implementing that interface I'm sorry, it was not implementing. It was using that interface. The low level module was also depending on it, and the interface abstract only. It will hide the implementation details. Nothing will be here, only the declarations are here. The next is abstraction should not depend on details, and details should depend on abstraction. That is what I have discussed right now. The abstraction, that is an interface, it should not know how things are getting done. For example, in the example that we have just discussed, the interface, it was not dealing with how the light is getting turned on. It was just declaring a method. If you look in here, it was just here. It doesn't have any implementation details over here. It just declares the method, right? And the details like the class or fan should conform to the abstraction. It means the details, light or fan class should have all the implementation details in it. So that was it about DIP. If you have any questions, please let me know in the comment section. Thank you.